First one is physical processes. As I said, physical process means you can measure quantitatively. So that was not quantitatively, like something you can see, something you can feel in a way. So when I say physical process, I'm talking about sediments or just water infiltrations. So sedimentation is also physical process. But I'm not going to discuss sedimentation here because we discussed that for ponds in earlier classes. Just know that the same concept applies here. Sedimentation is not a big factor here because the amount of water returned on the top is very small component of it. So that's why you don't really rely on sedimentation that much, but you do rely on infiltration process. So infiltration means infiltration of water. So now question is what controls infiltrations or infiltration or filtration. Infiltration means it's just, uh, let's see, right? Infiltration means what? Infiltration is water moving through pores. And when I say filtration, it's removal of particle um, from water by straining. Straining means you have a pores, that pores are so small that the particles will stop there. So what control filtrations or filtration or infiltrations? Both, because both are physical process. Infiltration, that this is determined by the hydraulic conductivity of the filter media. So infiltration depends on K or hydraulic conductivity. And we know that before, hydraulic conductivity. And you can change that by particle size, all that other factors that you learn. But control filtration is also particle size, but mostly you are thinking of the pore space between particle size. We also learn about filtrations, that collision efficiency, and all that factors that we learned in the previous classes. We have some of them will be in the quiz, so you know those content. So now question is what designs are needed to meet infiltration capacity. So infiltration capacity, it means how much stormwater can infiltrate within certain time. The goal here is roughly 10 inches per hour. So whatever filter media you use, you should drain water as fast as 10 inches per hour. If it's going a lot slower, then those are not useful for stormwater treatments because you'll receive lots of stormwater in these areas. So what design are needed to meet? So what you can control is particle size. If you increase particle size, you have typically more space in between them when you pack them. That way you can infiltrate more water. If you want to say what controls the filtration capacity, filtration means removal of sediments or particles, is the space between them. Then you can actually decrease particle size. That way you can remove some more sediments. So that's why you have to have a balancing act. You do not want to add too big particles like gravel, but you want to add smaller enough particles like sand. So mostly the design is sand content. So if you have higher sand contents, that has more infiltration capacity. Typically, sand is 50 to 70% of, or 40 to 70% of filter media. If the soil is already sandy, you don't add too much sand. That's why 40%. So you can control the amount of sand you mix with the media, then you can get this capacity. Lots of time people don't really buy sand. What they do is they buy a sandy soil. So sandy loam or sandy soil, for instance, sandy loam. This is what people use for biofiltration system filter media. Next one is clogging. As I said, there is an advantage, disadvantage of having small size particulates. If you have very small size particulates, they can they can remove lots of sediments or particulate polygram, but they can also get clogged in the process. So the reason it clog is because if you take the top layer, let's say this is particulates. So you have very small particles build up here. And then eventually these pores are going to be clogged. Pores are filled with fine particles. So when this happens, then it doesn't really, it loses infiltration capacity at that layer. And usually clogging occur at the very top layer because that's where most of things accumulate. It doesn't uniformly clog entire system. So it occurs again because of filtration of sediments. Now this is a graph that shows, I will just show you this graph, what controls clogging is the particle size, how it occurs. So particle size of filter media is which can affect clogging rate. For instance, if you see this graph at the this case over here, the left side, the bottom line is amount of sediment received. So that will be sediments is gram, and then per meter square of the biofilter area. So that's the surface area of the filter. And so if you plot that one, as you see, hydraulic conductivity initially when you design it, it is very high. As you add more and more sediments, it decreases to very small number. As long as this is still bigger than the design limit, is fine. But here, if you see three different media, so this is small, that's the filter media, which is smaller size. This is the size range in micrometers. So that's the fine or medium grain sand. And if you go here, this is coarse sand or coarse sand range. And this is mostly above 2 millimeter will be gravel. So this is coarse to gravel range. So if you have different range of particles, in this case biochar, they clog different rate. And the one which is the smallest particle, small size filter media clogs faster. Okay, that's because it has pore size, and you can actually model that. So if your hydraulic conductivity is K initial at any time, you can calculate by e to the power minus R L. Okay, so L is sediment loading. That means how much sediments per unit area. This is the unit is gram per meter square in SI unit. And K0 is initial hydraulic conductivity. That's what it started with, and then it decreases exponentially. And R is a coefficient that determines what's the interaction of the sediments with the particulates. So R is a function of particle size, and so D means the size of the filter media. Small d is the size of the sediments that you receive. If you have larger sediment, they will clog faster. And also it is also depends on the interaction force between the sediments as well as your filter media. So that's the clogging. So we learn about everything about physical process now. Any question?